Algebra 1. We are on lesson 2-1. Thank you, Montse, for hitting the lights. So we have a lot of vocabulary review because today we have a short lesson, which means we should be able to finish the Khan Academy assignment today in class. So some of these we did for the warm-up, so they should be reviewed by now, which means it's easy XP. But some of them are maybe not reviewed. Okay, so constant. Quiet raised hand. Constant. What is that? If I say, this is a constant, what am I saying? That is a constant. Fernando has an idea. Keep thinking, keep thinking. I want to see one more hand. What is a constant? It's a fancy way of saying something that you do already know. Go for it, Fernando. It's just a number. So constant is like 1. It's like 5. It's like 10. Those are constants. It's just a number. Write the hashtag, write the octothorpe. It's just a number. Notes are supposed to be fast. You don't have to write out the word NUMBER. Just do the hashtag. All right. Term. We did define this earlier today in the warm-up. What is term? Quiet raise hand. Easy, easy XP here. Sergio.
Variable, number, or both.
Variable or number or both. So an example would be like 3x or x. Those are variables. This is a variable. This is a variable with a constant, with a number. So a term is a variable or a number or both. Very nice. All right, expression. Josie. Can you say it again but louder?
Expression that doesn't have equal sign and it's separated by minus.
Close. So I think you meant to say equation without an equal sign, right?
Yeah.
Yeah, so that's the way that we define it in the warm-up. So I don't want to write that one down here because there's a slightly better way to say it. I'm still going to give you your XP for that. In fact, I should be giving everyone their XP for this. My mind is foggy. Who already got the XP for the last two? So constant, that was Fernando. It was Fernando and then Sergio, right? So there's Sergio's 50 XP. Oh, oops, that's my bad. And then there's Fernando's 50 XP. Got a little bit more XP. You're welcome. Okay. And then Josie, there's your XP. I'm gonna give you correct because you have it correct. I just want the other definition that we have for expression. Let's give it because you have it. So I want to hear from Andres to say it again.
A group of terms that, yeah, a group of terms
What are they separated by?
by like the separated by like minus signs or
By
addition signs.
minus signs and addition signs, exactly. Let's write it down in our notes. Everyone should have this. We've defined this before in Unit 1. I'm defining it again in Unit 2. You just need to always have this in the back of your mind. What is an expression? And then today we are formally defining an equation. Unit 2 is all about equations and how to solve them. So equation. Anyone want to take a guess at an equation? Somehow using this word expression. Expression should be in the definition of equation. Each of these goes into each other. Constant is used by term, term is used by expression, expression is used by equation, and equation is used by solution. Equation. Anyone want to take a guess? All right, so an equation, oh, sorry, go for it, Gunnar.
Expression with equal sign.
Yeah, you're really close. So it's two expressions.
I was gonna say that.
On either side of an equal sign. I'll just put it right here. So let me give Gunnar your 50 XP and do that as it happens on either side of an equal sign. So I want to just hopefully have a little bit of room in the bottom right hand side down here to give it an example. So like 3x plus 1 is equal to 5x minus 3. This is an equation because 3x plus 1 by itself is an expression. 5x minus 3 by itself is an expression. 3x is a term, 1 is a term, 5x is a term, 3 is a term, and the constants here are 1 and 3, or minus 3, depending on how you look at the problem. So each of these words has now been defined, and you can actually see an example of it just in this one example. All right, and then solution, I think Mr. Sindel is going to define this one for us. This is the value, and I'm going to do in parentheses S because it might be multiple answers. It won't be multiple answers in Unit 2. It will be multiple answers in Unit 3 or 4. I don't remember when we get more than one answers. But it's the values of the variable that make the equation true. So if I solve for the equation, I say x equals 1, then that is the solution, because when I plug in 1 into x, then I get everything equal to each other. The left side equals the right side. All right, lots and lots of vocabulary, and some of this, most of this, hopefully should be review. So let's look at an example for tonight's homework. So, which value of z makes 3 plus 2 times the quantity of z minus 7, n quantity, is equal to 7a? Or 7, okay, and then it says a true statement. I should probably move that to the other line. A true statement. So how do I make this a true statement? Which one of these, and it's only one of these answers, which one of these answers makes it a true statement? The way that I'm going to solve this is by just plugging in each of these z values to see which one works. Are you ready? We can do a lot of mental math here. You don't have to show your work if you are strong enough at mental math. If you do want to write it down, go ahead and do it. On the test, I am going to make sure that you write it down. So I'm going to write it down for the first two, and then we can do mental math for the rest. So first two, write this down with Mr. Sindel. 3 plus 2 times the quantity of, leave it big. So z is going to have the parentheses because I'm substituting something in for z. 8 is now being substituted in for z. So there's my 8 being substituted in, minus 7. I need to finish writing the equation. Right now we just have, what is this thing called? The left-hand side of the equation. It's one of these words up here. What did I just write down right now?
Expression.
An expression. There it is, Andres. So I have an expression now, and in order to make it into an equation, I have to write my equal sign. It's an equation now. Is equal to 7. Got a little bit of lag there. All right, is this true? Is the left-hand side equal to the right-hand side? Well, let's go through it. 8 minus 7, shout it out.
1.
1. And then this whole thing is 1, so 1 times 2 is, shout it out.
2.
And then 3 plus 2 is, uh-oh. This whole thing is 5. So this turned into, we'll do an arrow here to say it, turned into 5 is equal to 7. That's not a true statement. A true statement is the left-hand side equal to the right-hand side. So we can immediately say, nope, wasn't A. Try it again. Let's go ahead and write out the math for B. So I'm rewriting the same equation, but instead of an 8, I'm going to put in a 9. So 3 plus 2 times the quantity of, substituting in the 9, don't forget your double parentheses, minus 7, n quantity is equal to 7. So what does that thing turn into? All right, we're going to do mental math as a class. 9 minus 7 is? 2 times 2 is? 3 plus 4 is? 3 plus 4 is?
7.
7. So you have 7 equals 7. Hey, there it is. We have a true statement. A true statement. It's B. So if we take a look at C, if we plugged in 10, we would have 10 minus 7, shout it out, is 10 minus 7.
3.
3 times 2.
6.
6 plus 3
9.
is 9 equal to 7. No, so it's not a true statement. And then you can go through all the rest of them as well. But the answer was B. And our second and final example before we move on to actually solving equations. Now we have to select all the equations. All the equations. I'm going to underline all because there's going to be multiple answers. In fact, it tells us there's going to be 3 answers. All equations where b equals 3 is a solution. This means that we're going to be substituting b equals to 3 in for b, and see if it's true. So if we sub 3 in for b, 3 plus 12 equals 15. Does the left-hand side equal the right-hand side? Therefore, it's an answer. All right, let's plug in 3 again. 9 times 3, is that equal to 27?
Yes.
Okay, that's another answer. 8 minus b, that's 8 minus 3 now. Is that an answer? Shout it louder, please.
No.
No, it's not, because that would be 8 minus 3, which is 5. 5 is not equal to 4. Let's try this one. 9 is equal to 27 divided by b. What's 27 divided by 3? 9. 9 equals 9. Ah, there's our third answer. Process of elimination, it's not E, but let's go ahead and check it. B divided by 3. What is 3 divided by 3? 1. 1 is not equal to 6. It's not E. It was A, B, and D. If you know how to do those 2 examples, you are ready for the homework. Give me a fist of 5. How comfortable do you feel doing the homework tonight, doing these types of problems? I see the lowest is a 4. Most people doing 5s. Okay, cool. And of course, if you have any questions, I'm going to be walking around and helping us. All right, so we're not actually solving equations tonight for the homework, but I just want to get you set up for tomorrow night. Just have this in the back of your head. The idea of an equation. So an equation, I never really see an equal sign when I'm looking at a math problem. I always see a balance, a scale, if you will. So I want us to go ahead and draw a picture. So if I have a scale and I say I have some unknown quantity, so I'm going to do a question mark here. This question mark I'm going to put inside of a block, because usually when you put things on a scale, they're blocks. You put blocks on a scale and you see which one is equal to which one. I also know that I have this 1 kilogram block and this 1 kilogram block. So I have this unknown quantity plus a kilogram plus another kilogram. I also, on the right-hand side, I have a bunch of these 1 kilogram blocks. So go ahead and make a bunch of these 1 kilogram blocks. Like so. I end up drawing 7 of these 1 kilogram blocks on the right and only 2 1 kilogram blocks on the left. When I'm solving an equation, tomorrow when I'm solving an equation, are you ready? Okay, Cohen? I see you staring at your laptop, so. Okay. When I'm trying to solve an equation, I'm trying to solve for this unknown quantity. Usually in an equation, we leave that as a variable x, just to distinguish the difference between unknown quantities. If I could do a question mark for every one of these up here instead of a b, that would be awesome. The trouble is, I have to have different question marks. I have to have like an orange question mark and a blue question mark, and because we don't all have color printers, we all just say, okay, well, let's say that one's y and that one's x. That's the reason that we do variables with letters instead of just doing different colored question marks. So coming down here, I need to figure out how much this unknown quantity is, but I can't figure that out because I have this extra 2 blocks here. So what I could do is I could just say, okay, well, remove this block, remove that block, take it off of the scale. So go ahead and cross this off. Just take it off the scale. The problem with that is now the scale is unbalanced. Now this right side would move down and this left side would move up because I have unbalanced this scale, unbalanced this perfect equality. So in order to make sure that the scale stays balanced, what I have to do is I also have to take off 2 on the right. By taking off 2 on the left and 2 on the right, the scale stays balanced. And now I have solved for this unknown quantity. The unknown quantity is by itself. It is isolated. I always use the word isolate. It's by itself, so we know that this unknown quantity is 1, 2, 3, 4, 5 kilograms. When I say do the same thing to the left and right side of the equation, it's not just some rule that you need to memorize. It's really just trying to preserve this balance. I want to show you a different example of what could happen. What if I had 2 unknown quantities? So a question mark and a question, oh, that's not a question mark, and a question mark. I had 2 unknown quantities, and let's just go ahead and write 6 of these 1 kilogram blocks on the right. Well, now it's hard because I want to get just 1 unknown quantity. So it would be awesome if I could just take off this 1 block, but the problem with just taking off this 1 block is how many blocks do I take off the right-hand side? Do I take off 1, 2, 3? Maybe I take off all of them. I don't know. So you can't just take it off. But what I could do is I could look at the problem a different way. Instead of just taking off 1, I could take off half. If I take off half of 2, that means I'm taking off 1. Half of 3 means I'm taking off 3. By taking off half of each side, I preserve the balance, and I still get this unknown quantity by itself. This unknown quantity happens to be 3. And here's the key part of today's lesson, which I will be re-emphasizing tomorrow. We do the same operations to both sides because we want to preserve the balance. I should say we need to keep the balance. And I have these extra scales down here in case we have another example that we need to go through, but I don't think we need to. That's good enough for today. Are there any questions about today's notes? All right, go ahead and write your summaries. After you finish writing your summary, check someone else's, see if they have something that you can add to your summary. And when you finish your summaries and check in your summaries, go ahead to go on Khan Academy and do the problem set.